Hello everyone. Today we're going to be solving logarithmic equations. Let's go ahead and begin with this quick warm-up. Oops, okay. Alrighty guys, so using the notes from yesterday, you're going to go ahead and solve this exponential equation. So go ahead and pause the video right here and solve for the value of x. Okay. Keep in mind you want to go ahead and find something with the same base. Okay, so go ahead and pause the video and give it a try. Alrighty, so by now you would have probably been thinking like, oh, let me see, I got a 4 and I got a 16. They're both even, so probably 2 is a good base. I agree with you, 2 is a good base, but there is one better, and we can go ahead and also see that 4 is also a factor here. So keep in mind, both of them will work, but if we go ahead and use 4, we're going to go ahead and see that on the left-hand side, we would not have to change anything. It's already a base of 4. So I'm going to go ahead and go with 4 raised to 3x. And notice I did not have to worry about anything. The only thing now I do have to worry about is the right-hand side. So that's telling me that 4 raised to some number, 4 raised to some number, right, is going to go ahead and give me 16. Whatever that number is going to be the exponent right here. So this one isn't that bad. Keep in mind it's just a warm-up. So 4 times 4, it gives me 16. So 4 squared, this should be 82. Okay. Now we have the bases are the same, right? So we have the same bases. Therefore, we can set the exponents equaling to each other. So we have the exponent right here. On the left is going to be this 3x right here. And we have the exponent on the right is 2. Setting them equal to each other, we have 3x is equal to 2. And all I have to do now is solve for x. Solve for x. Okay. So we can divide by 3 on both sides to get rid of the multiplication of 3. This is equal to 1, so x is equal to the right-hand side, which is 2/3. So my solution here is this right here, 2/3. Then again, you can go ahead and substitute, and you can see that it does work if you wanted to. So 3 times 2/3 simplifies to 4, 6/3, which simplifies to 4/2, which indeed gives us 16. Pretty cool, right? Alrighty, looking at today's week at a glance, we're already on Thursday, right? Today we are only going to have an exit ticket due, since I know a lot of us are stressing out about the quarter finishing, and that will give us a little bit of time to finish up and catch up on any assignments that we have. Keep in mind that 3.6 is due tomorrow. Okay. Oh, fun fact, ACT is still due, it's still going to happen on Tuesday. And we have a unit exam on Wednesday of next week. Okay, cool. Today we're going to go ahead and work with logarithmic equations by using properties of a logarithm. So power rule, compression, expansion, and stuff like that. So pretty much the same ideas from yesterday, but now using logarithms. Okay, so go ahead and write down these notes right here. And we have 3 different cases at which we can approach these logarithms. So case number 1 tells us that we only have a log on one side, So we can see right here. The log is on any side is equal to a digit, right? So that is the first case. And I want you to refer to the Snail method, okay? And we'll do some examples. This example will be 1 and an example 2. We'll go ahead and help us with case number 1. Case number 2 tells us that we have logs on both sides. So we're going to go ahead and see we have logs with both sides with the same base. This only works if the logs have the same base. Okay, so if you have logs with the same base, what you can go ahead and do is you can get the parentheses and set them equal to each other. A lot of kids like to say that it cancels, but it does not cancel. You can go ahead and say that they simplify to 1 and therefore they're not there anymore. Well, pretty much like the exponents, we went ahead and had the exponents set equal to each other because the bases were the same. So you can go ahead and see that the bases are the same. So therefore, I can get the parentheses, set them equal to each other. And last but not least, I have this right here. I have the same idea from compressing and expanding, and you can see the plus and the minus, right? Remember, when you add, that's the same thing as multiply, and when you subtract, that's the same thing as division. So keep that in mind. When they have the same base, right? Logs with the same base, you can go ahead and either add them, meaning the parentheses, multiply, or you can subtract them, meaning you go ahead and set them in a fraction, the numerator and the denominator. So the important part about this is that when you do this, you obtain a case 1 or a case 2, and then you just work it like we normally do. So pause the video, write this down, or refer to your notes about compression and expansion and the Snail method. Okay, alrighty. So case number one, it's gonna go ahead and be the Snail method, right? Because I have a log on one side with a base of 2 and a digit on the right. And I want to go ahead and get rid of that log. And we can go ahead and do that because the inverse of a log is an exponential. So we're going to go ahead and do that right here. I have the 2 is going to become the base of the exponent that is raised to the 3. So let's go ahead and rewrite this. I have x plus 2 is equal to 2 to the third. Okay. So let's go ahead and simplify the best that we can. We got x plus 2 is equal to 2 to the third, which is the same thing as saying 2 times 2 times 2. So x plus 2 is equal to 2 times 2 times 2, that's 8. And we can simplify. Minus 2, x is equal to 6. This right here is our solution. Okay. Alrighty, if you do have questions, guys, please refer to the notes. If not, send me a Teams chat and stuff, email or whatever the case may be, and I'll help you out. I do have another example. So pretty much when you have a log, right, a log on one side and a digit on the other side, you can do the snail method to get rid of the log and then just solve, right? Solve for x. Okay, so let's try that again. Let's try the next one. So case 2, hopefully this one's a little bit easier. What should be our first step? What should we be doing when we have a log on the left and a number on the right? So hopefully you are thinking about doing the snail method, right? Pretty much converting this log into an exponent. Okay, so I got the base right here is 3. It goes right here, and it becomes the base of the exponent of 2. So I'm going to go ahead and rewrite this because the new equation I'm trying to solve is x minus 5 is equal to 3 to the second. Okay, from here I got x minus 5 is equal to 9, right? Because 3 squared is 3 times 3, which gives me 9. Okay, alrighty, so I go ahead and solve for x, right? Solve for x, and I go ahead and see that I can add a 5 on both sides, get rid of the negative 5. So I'm left with x is equal to 9 plus 5, which gave me 14. Okay, and this right here is my solution. I should probably write bigger, right? Okay, let's go ahead and try a case number 2. Oops. Case number 2. Case number 2 is important. Well, actually, they're my favorite, but they're important because we can go ahead and see, get my highlighter, that these bases, log of 7, are on the same, have the same base. So what we can do is we can go ahead and see that all I have to do is set the parentheses equal to each other. Okay, so whenever you have logs with the same base equaling to each other, all you have to do is get the parentheses, get everything inside the parentheses, and set them equal to each other. So a lot of students like to say that it cancels, but no, this is a property that we can go ahead and set the insides equal to each other. The same way we did with our exponents, we had the same base. We got the exponents, set them equal to each other. Okay, and from here, guys, all you have to do is solve for x. Okay, alrighty, so not that bad. I got a 2 right here. I'm gonna go ahead and subtract it. So 1 is equal to 4 minus 2, which is 2x. And I'm gonna go ahead and get rid of that multiplication of 2 by doing division of 2. So x is equal to 1/2. This right here is a solution. Okay, so all of these right here have been positive answers. So I want you to start thinking about what was to happen if we somehow got x equaling a negative number. So let's go ahead and try that right here. So what I want you to know is when x is a negative number as a solution and you substitute it into your logarithm, and the final answer that simplifies inside the parentheses is negative, there's going to be a part that there's going to be a solution that we're going to go ahead and talk about, and we're going to call it an extraneous solution. Because it is, but it is, because we cannot evaluate logs at a negative input. And that goes because of the graph. Remember, the graph tells us that there are no values that are to the left of the x-axis. So keep in mind the logarithmic parent function tells us, hey, there are no negatives outputs, right? Or inputs. So pause the video, write this down. We cannot evaluate negative digits. Not to be confused with negative variables. We can have negative variables. We can have log negative x plus, I don't know, 3. We can have that. We cannot, however, have log of negative 2. That does not exist. You know what I mean? Know what I mean, Jelly Bean? Okay, so let's practice this. Case number 2. So do it the same way you've been doing it, but keep in mind we have to check for extraneous solutions. And you might not be able to see it here because of the little video thingy, but just keep in mind there's check for an extraneous. So right here, we should be referring to looking at, hey, look, there are logs with the same base. So I'm going to get the insides and set them equal to each other. So I got negative x plus 1 equals negative 4x minus 5. And all I want to go ahead and do is I'm going to go ahead and solve for x. Okay, so I have this negative 4x. I'm going to go ahead and add it, 4x on the left, add it on the right. And I have negative x on the left plus a positive x, so I'm left with 3x plus 1 equals negative 5. Okay, the next thing I'm going to go ahead and do is get rid of that plus 1 by subtracting 1 on both sides. So I'm left with 3x is equal to negative 6. Okay, very simple arithmetic. We're going to go ahead and divide by 3. Divide by 3. X is equal to negative 2. This right here is our solution. Okay. Now, we want to go ahead and check, is this an extraneous solution? So we always want to go ahead and check, because I'm saying that it's a solution, but I'm getting ahead of myself because it might not work. So we're going to go ahead and check for extraneous solutions. Okay, let's see if I can move that video out of there. No. Okay, so how do we do that? We just substitute our x that we got, which in this case was negative 2, into these right here, into the left and on the right. And I know what you're thinking. You're like, hey, Pacina, won't it equal the same thing? For the majority part, yes. In this scenario, it will. But when you're getting compressed, expanded, stuff like that, it's always good to try it out. It only takes a couple seconds. So let's try the left, right? That tells me log of 3 negative x plus 1. And remember, we want to find out, does this equal a negative? I'm sorry, is there the final answer in here? The final answer inside the parentheses, is it a negative digit? So let's go ahead and try it. Log of 3 negative 2 plus 1. So we have log of 3 Negative, negative made a positive 2 plus 1, which look at that. This is a log of 3, base 3. So this is good. I'm assuming the right-hand side is going to be a log of 3. So it's going to be log of 3, negative 4 times the negative 2 minus 5. And I'm going to go ahead and simplify this. Negative 4 times 2 gives me an 8 minus 5. Quick maths tells us that this will be a 3. So notice how it did work. So it is a real solution for this because it is not extraneous, right? Okay, so how do extraneous happen? Well, let's go ahead and try case number 3. And I want you to think about what we can do before we try solving it. So keep in mind this log base 3, log base 3 are being added together. So I'm going to go ahead and see that once I add them together, I can go ahead and compress them by multiplication, right? All of this right here can be compressed by multiplication. Meaning I'm only going to have one log base 3, and then all of this in here is going to be x times x minus 8. And then all of this did not affect the 2, so all of this is equal to 2. Okay. Alrighty. Now, whoopsie daisy. Now that I want you to go ahead and see is, now that we see this, does this remind you of a case number 1 or a case number 2? Okay. So let's go ahead and think about that. What does this remind you of? What does this look similar to? Well, keep in mind, case number 1 was when a log is equal to a digit. Case number 2 is when logs are equal to each other, right? And those are based from the notes that we just took. So in this case, hopefully you're assuming that, hey, I have a log on the left and I have a digit on the right. So I have a log on one side, a digit on the other side. This is case 1, meaning I'm going to go ahead and refer to the snail method, right? The snail that converts this logarithm into an exponential. So getting rid of that log, or as my kids like to say, cancels. It does not cancel, guys. They're inverses. Therefore, they equal 1. Okay, anyways, x times x minus 8 is equals to 3 raised to the second power, right? And I could simplify everything here. I'm going to go ahead and distribute that x into both sides. So I'm going to have x squared minus 8x is equal to 9. Alrighty, from here, I'm going to go ahead and try to solve this the best that I can. So I'm going to move that 9 to the left. So this is going to give me the written form as x squared minus 8x minus 9 equals 0. Okay, now this looks very, very familiar. You probably were not thinking about this when you entered this class, but this right here is actually something that we can factor. And we've all been watching the factoring videos, so we kind of have an idea of how to factor. Some of us might be able to do it really quick, doing a guess and check, because we can think of 2 numbers that multiply to -9 and add up to -8. I like to tell the students that it's like a puzzle, like a little riddle. I'm looking for a number A that multiplies to a number B that has to equal to -9, right? This one number right here. And those same numbers have to add to equal to -8. So go ahead and pause the video right here and give those numbers a try. 2 numbers that multiply times that multiply to equal -9, but add up to -8. So what numbers you got? Okay, so hopefully you were able to come up with the number 1 and the number 9. So let's say -9 times 1 is equal to -9. And if I add them together, -9 plus 1 is equal to -8. So this right here is a -9 and a +1 is equal to 0. So I'm going to go ahead and write everything over here to give myself more space. So I have an x minus 9 is equal to 0, and then x plus 1 is equal to 0. Remember, factored form allows us to take each individual factor and set it equal to 0. So I can solve for this. X is equal to positive 9 and x is equal to negative 1. Okay, so be very careful when you have something like this, because you're going to go ahead and check for extraneous solutions. And it only takes about a second or two to substitute it in. And let me rewrite the question so it looks a little bit cleaner. So I have log base 3 x plus log base 3 x minus 8 is equal to 2. So I just rewrote the question. And I'm going to go ahead and check if I substitute my 9, right? Well, I'm going to do it by parts, but by 9 into my x's, will it go ahead and give me an extraneous solution? Okay, so according to this, I have log base 3, 9 plus log base 3, 9 minus 8. So is this something I can go ahead and evaluate? Is it a positive number? So if we check right here, the first log has log 3 of 9. So that works. It's a positive number. I could probably figure that out. Worst case scenario, I could graph it. Log base 3, 9 minus 8. Looks sketchy, but it's a log. If I simplify, it's 9 minus 8 is 1. So I could solve for that. So x equals 9 is indeed a solution, a real solution. The next one. How about when x equals negative 1? Ooh, let's try that. If I substitute into the first part, I get log base 3 negative 1 plus, let's stop right there, like, stop right there. Notice what we have here. I can go ahead and tell you, hey guys, this is not going to be a real solution, because look at the first one right here. I went ahead and substituted a negative 1, and it gave me this. So according to our notes, when we have a log and a negative digit, we have an extraneous solution. So that's all we have to do. So we have, let's go ahead and say x equals 9 is a real solution, right? And we have x equals negative 1, right? Negative 1 is an extraneous solution. Extraneous solution. Let me move the video. Okay, so how many solutions did this have? Well, at the beginning we thought it had 2, but in reality we saw that, hey, only one was real and the second one was an extraneous solution. So we ended up having only one solution. Okay, this is the harder part about this, finding out which one is the extraneous. But keep in mind, guys, let me get my laser. Keep in mind, at the beginning, all we had to do was compress, right? Then from there, we identified, is this a case 1, is this a case 2? And we were able to see that this was a case 1. So I did the Snail method, meaning I converted my logarithmic into an exponential, and then I simplified to solve for x. I had to do some factoring, but that's perfectly fine. That wasn't too bad. By factoring, I was able to find out 2 possibilities of these solutions, right? Degree was 2. And then I just checked them. I checked, hey, which one works, which one doesn't work, and stuff like that. Okay, so hopefully this video helped you out in learning this. I do have a math meme for us. A little bit of shade because we do have an exam on this coming Wednesday. So yeah, for the exit ticket, guys, this is due today at 5 p.m. And I went ahead and posted it on the assignments tab. So go ahead and solve the values for number 1 and number 2. So pretty much case 1 and 2 that I want you guys to go ahead and try. So as always, guys, it's been a pleasure. If you do have questions, send me a team chat, send me an email, and I will gladly help you guys out as best as I can. Thank you.